Hello, grade 11s. Welcome back to the channel. In today's lesson, we're going to be looking at Newton's law and we are dealing with objects on an inclined surface. So without any further ado, let's just get right down to the lesson. Ra. So now this is what I want you to comprehend before we can get to solving the questions that relate to objects being on an inclined surface. Here we have when an object is on an inclined surface, we resolve its gravitational force to two components, namely, number one, the Fg parallel, which is the parallel component of the gravitational force. Having the formula Fg parallel is equal to mg sine theta. Now the theta will be the angle that is formed by the incline. Now you must know one thing about the Fg parallel. We say this component always slides down the incline parallel to the surface. Then we have another component is the Fg perpendicular. We say this is the perpendicular component of the gravitational force. Having the formula Fg perpendicular is equal to mg cos theta. Now we say this force is perpendicular to the Fg parallel and the surface of the incline. Now that means if you have an incline sliding down to the left like that, even the Fg parallel will slide down to the left, right? And the Fg perpendicular becomes perpendicular to the Fg parallel, and you can see it is also perpendicular to the inclined surface, right? Now if your incline is sliding all the way down to the right, even your Fg parallel will slide down to the right, so it is parallel to that surface, right? And then your Fg perpendicular will form that 90 degrees with the Fg parallel and the incline, right? So that's what is going on there. Now let's get to the questions. Let's see what we are given here. Now question 5, it says a snowmobile pulls a 50 kg sled down a snowy hill that has a constant incline of 25 degrees. The snowmobile exerts a force F on the sled. Now we can see that we are given a diagram like that. Then just below the diagram it says the kinetic frictional force acting on the sled is 17.7 newtons. So we know we want to get that one highlighted, right? The kinetic frictional force acting on the sled is 17.76 newtons. So we are given the kinetic frictional force. Now 5.1.1 says state Newton's second law of motion. So we're just going to run quickly to that. Now we know it says Newton's second law states that when a net force is applied to an object of mass, the object will accelerate in the direction of the net force, where acceleration is directly proportional to the net force and inversely proportional to the mass of the object, right? So that's how we define it. Now 5.1.2 says draw a labeled free body diagram showing all the forces acting on the sled. So that's for 4 marks. We must show all the forces acting on the sled. Now we know if we are given 4 marks, that means we have 4 forces, right? So now let's draw that. Now because this is on an incline, I will try to just faintly draw the incline. Okay, perfect. Then now we know that sliding down the incline will be our Fg parallel, and then forming 90 degrees here will be our Fg perpendicular, then forming 90 degrees with the surface. We know that's our normal force, right? So how many forces have we got right now? It's only 2. Remember, these are components of your gravitational force, so they're marked as 1. Then what do we have? Because remember the snowmobile is going down the slope, that means we have our kinetic frictional force opposing the motion from that other side up the slope. right? Then what else do we have? We can see that we've been told that the sled is being pulled by a force, which is the snowmobile, right? So we'll say the force applied. Let's take the snowmobile as the force applied. Now that's how you have your free body diagram. How many marks? 4. So you have 1 here, 1 there, 1 here, and then 1 for the components of your gravitational force. Now 5.1.3 says calculate F, the force exerted by the snowmobile on the sled if the sled accelerates at 5 meters per second square down the hill, right? So we can see there that we are given what? We are given the acceleration. And remember, up here we have the kinetic frictional force acting on the sled, which is 17.76 Newton. So that will be of much help to us. Then let's calculate force F. Now we already have the free body diagram for the sled. So remember, now we will consider the horizontal forces, which is in this case, that's your Fk, and the force applied, and also the Fg parallel. So now let's come here and indicate the directions. So since we know that these ones are going in the same direction of motion, we will assign them the positive sign, and then since this one is going against, that one will be negative. So now having our F net, we say F net is equals to MA, right? So in this case, we have the force applied, which is the force that we are looking for, right? F. So we can just write it as force applied, then plus the Fg parallel, remember that in the same direction, minus the Fk, which is in the opposite direction. And then we have mass times acceleration. Now let's start to substitute. We don't have the force applied, remember? But then we know the Fg parallel is mg sine theta, right? Then minus Fk, so is equals to Ma. Then at this point, since we've broken down our formulas, let's just substitute. We have our force applied. Then what's the mass here? The mass of the sled we've been given to be 50. Then G is 9.8. And then sine, what is our theta? This is the angle formed by the slope, which in this case, it is 25 degrees. Then what's our Fk? Remember, on the statement we are given 17.76, and then our mass 50. But then remember, we've been given the acceleration to be 5 meters per second square. Now it's just a matter of saying Fa. Then we punch all that in a calculator. 50 times 9.8 sine 25. And what do we have? We have plus 189.32. Then on the other side, we have 50 times 5. And then that gives us 250. So the 189.32, we got it from saying 50 times 9.8 sine 25 degrees minus 17.76. Then we have 189.32, and then that is equals to 250. Now, let's continue. That means now we have force applied is equals to 250 minus the 189.32. Now we have force applied is equal to 60.68 Newton, if you round off to 2 decimal places. Nice. Now 5.2 says two spheres A and B having masses of m and 8 kg respectively, are connected by a piece of light inextensible string. They are pulled vertically upwards by a constant applied force P of magnitude 200 Newton. The tension in the string connecting A and B is T. Ignore the effect of air resistance. Then they say the net force acting on the 8 kg sphere is 40 Newton. So you also want to get that one highlighted. They say the net force acting on the 8 kg sphere is 40 newtons. Now they want you to calculate the mass m of sphere A. So we can see sphere A has been indicated by mass m and sphere B has been indicated by mass 8 kg. Now let's calculate. So having this, we can see that we've already been given the net force of the 8 kg. So we can go along to calculate the acceleration. But first, before we do that, let's see the forces acting on all the spheres. So for sphere A, we can see that what are the forces acting on sphere A? Sphere A is experiencing the force of P, which is that applied force, and then it is experiencing the tension downward, which is tension T, but then remember also it is experiencing the gravitational force, right? So the Fg. Now this is sphere A. What about sphere B? From the position that sphere B is in, we can see that it is experiencing the tension, which is in the upward direction, and also the gravitational force. Remember, the force applied is not on B, it is on A, right? So these are the forces experienced by the spheres. Now we know we draw the free body diagrams so that it makes it easy for us to calculate. Remember, if we see all the forces there, we know how to put our F net. So right now they say this is being pulled upward, so the positive direction is up and the negative direction is down. So positive direction up, negative direction down. Awesome. Now let's start calculating. So for sphere B, what are we given? This is the 8 kg, right? But then we were told that the F net is 40 Newton. So according to our second law, we have F net is equal to MA. Then F net, we have 40 here. Then what is our mass? That's 8. And acceleration. So we are looking for the acceleration here. So we're going to divide both sides by 8. Then our acceleration for sphere B will be 5 meters per second square. But remember, this acceleration for the 8 kg block is also the acceleration for the mkg because they're all moving as a system, right? So the 8 kg sphere, I meant to say, has an acceleration of 5 meters per second square, but also sphere A has that acceleration because they are a system. Calculate the F net of sphere B. So looking for the tension on sphere B. So what do we have here? We have F net, again, is equals to MA. But looking at our sphere B, we can see we have tension and Fg. So we can use that to calculate the tension because these two spheres are joined together by the tension force. Then T minus Fg is equals to MA, right? Now we have T, the Fg is mass times the gravitational acceleration. So remember our mass is 8, then multiply that by 9.8. And then we have here 8. But then remember the acceleration is 5. We have just calculated. Then now we have T is equal to 8 times 5. 8 times 5 we have 40. Then we can just transpose this one, 8 times 9.8. That gives us negative 78.4. But if we transpose that, positive 78.4. Now what is your tension? the tension at this point will be 118.4 newtons. So that's your tension. But remember, what are we looking for here? We are looking for the mass. So now that we have the tension and we see the tension is both on sphere A and sphere B, we can use this tension to now calculate sphere A, the mass of sphere A. So for sphere A, we have F net is equals to mass times acceleration. Now remember here, what are we saying? We are saying that the positive direction only has the force of P, and the negative direction has Fg and tension, right? So now we go force of P minus the tension and minus the Fg is equals to mass times acceleration. But we are given there the force of P. So they said they are pulled vertically upwards by a constant applied force of magnitude 200 newton. So let's have that one highlighted, 200 newton. So the force of P is 200 newtons. So we have 200 minus the Fg is the mass. So what is the mass? We don't have the mass. Multiply by 9.8, and then that minus T is equals to the mass multiply by 5, which is the acceleration. Remember, we said the acceleration of sphere B is also the same as the acceleration of sphere A. Now, having to deal with that, now we have 200 minus 9.8 meter. But remember, we do have the tension here from the previous question. Remember, they have the same acceleration and also the same tension because they're pulled by the same rope. So we have 118.4 is equals to 5m, right? So at this point, we can just transpose everything that has the variable m to one side and leave the constant in one side. So we have 200 So we have 200 minus 118.4 is equals to 5m plus 9.8m, right? So 200 minus 118.4, that gives us 81.6, and then 5m plus 9.8m, that gives us 14.8. Then divide both sides by 14.8. Divide both sides by 14.8. Then we have m is equals to 81.6 divided by 14.8. That gives us 5.51 kg. Right. Awesome. So that's it for the question. We have found the mass. Let's go to another one. Question 5, it says a crate with a mass of 25 kg slides down a plane which is inclined at 15 degrees to the horizontal. During the first part of the motion from A to B, there is no friction between the crate and the plane, but part BC has a rough surface. Now they say 5.1, draw a free body diagram showing all the forces acting on the crate while it moves from B to C. So while it moves from B to C, note that B to C is a rough surface. That means there we know that it will experience frictional force. So we have 3 marks. That means we have 3 forces. Let's go. So again, faintly show my incline. And then let's draw. So we have the dot indicating the object of interest. Then remember, sliding down the incline parallel to the slope will be our FG parallel, and then forming the 90-degree with the slope will be FG perpendicular, and then right above will be our normal force, and then we have two forces already, but then we know at part BC it experiences frictional force, so we have our FK there. So how many marks have we got? 3. So we have 1, 2, 3. Awesome. Now they say 5.2, calculate the magnitude of the acceleration of the crate while it moves from A to B. So if it's moving from A to B, we know the forces that are here, the forces that we are seeing here is FG parallel, and then FG perpendicular, then we have our normal force. So we can see that there are only two forces acting on the surface while it slides down from A to B. Remember, A to B, there is no friction. That is a smooth surface, right? So that means our F net will only be formed by this horizontal force here, FG parallel. So having to calculate that one, we'll say F net is equals to what? MA. But then the only horizontal force forming the F net is FG parallel. So we say FG parallel is equals to mass times the acceleration. So here we have mg sine theta, remember, and then we have MA, right? So what is our mass here? The mass is 25. And then we have our gravitational acceleration, that's 9.8. Then sine, what is the angle formed by that incline? 15 degrees. Then our mass is 25. And then we have A, the acceleration, right? Now having to punch that in your calculator, what do you have? It's 63.41 is equals to 25A. Then we know at this point we say 63.41. 0.41 is equals to 25A. Then we can divide both sides by 25. Divide both sides by 25. Now we have 63.41 divided by 25. Our acceleration will be 2,53 meters per second square, right? So we have it like that. Awesome. Now 5.3 says write down the direction of the acceleration of the crate while it slows down. So we want to highlight that slows down, right? From B to C. Write only up the slope or down the slope. So we know when they say an object is slowing down, this is what we call deceleration or negative acceleration. So we know that the crate is moving down the slope, but because we are experiencing a slowing down, a deceleration, that means now our acceleration is in the opposite direction of motion. So the correct answer here has to be up the slope, right? So we say it's up the slope, right? So because we are having a negative acceleration or a deceleration, which will be opposite to the direction of motion, up the slope. Now 5.4 says the magnitude of the net acceleration from B to C is 1.2 meters per second square. Calculate the magnitude of the frictional force acting on the crate. So now we are on the part B to C. But remember, we have a free body diagram for that, right? So we know that our horizontal forces are FG parallel and FK. So now knowing that the crate is moving down the slope, we will indicate this is the positive direction and this one is against the motion, so it's the negative direction, meaning that the two forces that are making our F net in part BC is FG parallel and the kinetic frictional force. So now let's calculate. We have F net is equals to MA. Now we have FG parallel minus FK is equals to mass times acceleration. Now we have already calculated this one from the previous question and got 63.41. So that minus the FK. So we have FK. And then what is our mass? The mass is still 25. And then we've been told that the acceleration on that part is 1.2, right? So now we have 63.41 minus FK. That gives us 30. Now what can we do? Let's transpose the FK to that other side. So we have 64.41 and then transpose the 30 to the left hand side, minus 30, and then is equals to positive FK, right? So at this point, let's calculate what will be the value for FK. What is 63.41 minus 30? 83.41 newtons. Awesome. And that's it for the question. Let's get to the other one. Now, question 5 says 2 blocks of masses 7 kg and 5 kg respectively are connected by a light inextensible string that runs over a light frictionless pulley as shown in the diagram below. The 7 kg block is pulled to the left with a force of 68 Newton at an angle of 12 degrees to the horizontal. The 7 kg block experiences a frictional force of 6 newtons. So we are told there that we have a frictional force of 6 newtons, right? And then the coefficient of kinetic friction between the 5 kg block and the surface of the incline is 0.18, right? Now 5.1 says define the term normal force. So let's run quickly to that. We say normal force is the force or component of a force which a surface exerts on an object with which it is in contact and which is perpendicular to the surface, right? Now we have 5.2. It says draw a labeled free body diagram to indicate all the forces acting on the 5 kg object, and we are given 4 marks. 4 marks means 4 forces. So let's check. What are the forces that we have there? We know sliding down the incline, we have our FG parallel, and perpendicular to that we have FG perpendicular. Then above we have the normal force. Then remember we have the rope there which indicates the tension, but then this is being pulled up, so the 5 kg block is also moving up the slope, so that means FK is acting down the slope, right? So that's how we have it. That's our free body diagram there. So 5.3 says distinguish between static friction and kinetic friction, right? So what is static friction and what is kinetic friction? We say static friction is the force that opposes the tendency of motion of a stationary object relative to the surface, but kinetic friction is the force that opposes the motion of a moving object relative to the surface. So static friction is whereby now, this is the friction whereby the object is stationary, but kinetic friction, this is the friction whereby the object is now in motion, right? So 5.4, we say calculate the frictional force acting between the 5 kg block and the surface of the inclined plane, right? So we have the free body diagram, and then we can see that the forces acting horizontally here are your FK, FG parallel and tension. But then to calculate the FK, we know that we have the formula to calculate Fk, if Fk is equals to mu k times n. And you will remember that we've been given the mu k to be 0.18, right? So that's 0.18. Now, if we look at our free body diagram, we have to calculate the normal force. But the normal force here, we can see that it is equivalent to the Fg perpendicular. So the normal force in this case, when it is on an incline, the normal force, we say it is equal to Fg perpendicular. So always note that whenever we are on an inclined surface, the normal force is equal to Fg perpendicular. Meaning in this case, we have what? We have normal force is equal to Fg perpendicular. So we can start by calculating the normal force, which now we know this is mg cos theta, right? So what do we have for our mass? The mass, we are given 5. Remember, we are calculating for the 5 kg block. And then here we have 9.8. And this is cos, what is the angle there that we have? 30 degrees, right? So we have 5 times 9.8 cos 30 degrees. That gives us 42.44 newtons. So that's our normal force, right? That's our normal force. Now, having to calculate the Fk, we say Fk is equals to mu k times n, right? But remember, mu k is equals to 0.18, the kinetic friction, the coefficient of kinetic friction. So let's write it nicely. 18. The normal force now is 42.44, right? So now 0.18 times 42.44, that gives us, if we multiply the two, we have 7.64 newtons. Awesome. Now 5.4.2 says, calculate the acceleration of the 7 kg block. So now we know with the strategy that we've been doing with the tension and acceleration question, we know that once we have a question saying calculate the acceleration or the tension of a 2-block system, and then we are given 7 marks, we know that we have to apply simultaneous equations. And then what we need to have here is we need to have the information for both the diagrams, right? So we need to have free body diagrams of both the objects. So now what do we have in this one? We have the Fg. Remember, this one is not on the incline. It is on the horizontal surface. And then we have our Fg. We have our Fn, sorry. And then that side we have the tension. And then also the kinetic frictional force. And then going to that direction, we have the horizontal component of the force. Remember, the force is now acted at an angle. If it is acted at an angle, we can resolve it to two components, the Fx and the Fy, right? So the vertical component will be going up since we are pulling it up, right? And then we have our horizontal component going to the left because it is being pulled to the left, right? So these are all the forces that we have there. But then remember, we are only focusing on the horizontal forces. So we have on the positive direction the horizontal component of the force, and on the negative direction we have the Fk and the tension, right? So if we start with the 7 kg block, let's start with the 7 kg block. So we're going to say for 7 kg, we have F net is equals to mass times acceleration. Then we have Fx minus Fk minus the tension, right? And then we have Ma, right? Then remember our Fx is F cos theta. So what do we have for the force there? We are given 68. Then cos 12 degrees. Remember the theta here that we are speaking about is the angle that is formed by the force, right? It is not the same as the theta for your mg perpendicular or your mg parallel. The theta there is for the slope, but the theta here is for the angle that is formed by the force. Then we have our Fk. Have we been told about the Fk? Remember, they told us that the Fk here is 6. If we look at the statement there, it says 7 kg block experiences a frictional force of 6 newtons, right? Of 6 newtons. So there we have it here. Now we have our mass again is equal to 7, but then we don't have the acceleration, so we have 7a. Then here, okay, before I write that one, we have here minus t is equals to mass 7 and then a. Now if you punch this in a calculator, all the 68 cos 12 degrees minus 6, what do we have? It's 60.514 minus t is equals to 7a. So I'm just going to round off to 3 decimal because we haven't arrived to the final answer. Then let's make t the subject of the formula here, so we can have 60.514 minus 7a is equal to t. Then we can just name this equation 1, right? So it's in the form of t. T is the subject of the formula. Then let's go for the 5 kg block. We indicate for 5 kg block. For 5 kg block, we have now the 5 kg block has the tension minus the FG parallel minus the FK, right? Is equals to mass times acceleration. Now remember, we get it from where? All the way back here, right? So the positive direction is the tension, and the negative direction is the one that is FK and FG parallel, because now the block, remember, is moving up the slope. So up the slope becomes the positive direction of motion, and down the slope becomes the negative direction of motion. So that's how we have all that. Now let's continue. We have T. Then remember our FG parallel is mg sine theta minus the Fk is equals to ma. Then at this point we can just substitute our values. Then the mass is 5 times 9.8, and then we have sine 30 degrees minus the Fk. Remember, we have calculated the Fk on the previous question. That's 7.64 newtons, right? Then what is our mass is 5, and then remember we don't have the acceleration, so that's 5a, right? So punching all this in a calculator, now we have negative 5 times 9, negative 5 times 9.8 sine 30 degrees, that's 30, minus 7.64, that will give us negative 32.14 is equals to 5a. Now again, if we can make t the subject of the formula here, we have t is equals to 5a plus 32.14, and this could be our equation 2. Now we know at this point we have to equate the two equations, right? So we take equation 1 and equate it to equation 2, right? So now let's do that. Now we have to equate equation 1 and equation 2. So for equation 1, what do we have? We have 60.514 minus 7a, then equal that to equation 2. For equation 2, we have 5a plus 32 0.14, right? So that means here, if we can just transpose everything that has A to one side and also deal with the constants on one side, so we have 60.514 minus 32.14. Then on that side, we have 5A plus 7A, right? Then punching that in a calculator, 60.514 minus 32.14, what do we have? We have 28.374, and then 5A plus 7A gives us 12A. Then dividing both sides by 12, our acceleration is equals to 2.36 meters per second square, right? So that's how we have our acceleration. Awesome. Now 5.4.3 says, now calculate the magnitude of the tension in the string between the blocks. So now since we know this is moving as a system, it has the same acceleration and also will have the same tension. So in that case, we can just pick out any equation, either equation 1 or equation 2, and substitute our value for tension, right? So let's say we are picking equation number 2. So we have T is equals to 5A plus 32.14, right? Then remember our acceleration is 2.36, and then we have that plus 32.14. So if you punch all that in the calculator, you have 43.94 newtons. So even if you substitute in equation 1, you will have more or less the same answer, because I think when you substitute in equation 1, you have something like 43.99, which is only a difference of the digits, right? So still more or less the same answer. If you just consider rounding off to the whole number, that will be 44 newtons. So that's it for this question. All the best. Keep on practicing. Ra.